Chapter 9, Section 5, Congruence Transformations. So figures are congruent if and only if there is a sequence of rigid motions that maps one figure to the other. So we've talked about congruent figures before, and especially congruent triangles and the different ways that we can prove them congruent. But the other way to prove two figures congruent is by looking at the transformations, the rigid motions. They're only going to be congruent if it's composed of rigid motions, so not dilations. So to find congruent figures, look for sequences of translations, rotations, and reflections that map one figure to another. Sometimes it's only one transformation, sometimes it's a sequence. So for example, because a rotation of 180 degrees around the origin of triangle DEF gives you triangle LMN, that means that the triangles are congruent. So triangle DEF was rotated 180 degrees, and it's always counterclockwise unless it specifies otherwise. And that gives you triangle LMN, which means that these two triangles are congruent because they were rotated, and a rotation is a rigid motion that preserves distance and angle measure. Because figure ABCJ was first reflected across the y-axis and then translated -1, +5 to give us figure WXYZ, the trapezoids are congruent. So if we look at ABCJ, it was first reflected over the y-axis, so it was reflected over here, and then it was translated left 1 and up 5 to give us figure WXYZ. Therefore, since it was made up of a composition of isometries of rigid motions, distance and angle measure were preserved, so these two figures are congruent. And finally, it even works with line segments. Because line segment HG was translated left 2 and up 9, the line segments are congruent because a translation preserves distance. Now, if we were to verify the side angle side postulate, it would be given that angle J is congruent to angle P, that side PA is congruent to side JO, and FP is congruent to side SJ. So we know that these two triangles are congruent by side angle side, but to verify why it works, we can look at a series of rigid motions. Step 1 would be to translate triangle PAF so that points A and O coincide. So we would basically be overlapping A and O. Because PA and JO are congruent, you can rotate triangle PAF about point A so that PA and JO coincide. So when we translate this over, and then we rotate this whole triangle so that PA and JO coincide, and they'll be perfectly overlapping. Step 3 would be to reflect PAF across line segment PA. So once they're lined up, because it would be rotated and this would be facing in the other direction, this would be PA right on top of JO, and we would reflect it across that so that angle J and angle P are overlapping, and since they're congruent and these two segments are congruent, we know that the reflection maps angle P to angle J and side FP to side SJ. Therefore, they will perfectly coincide, so there's a congruence transformation that maps triangle PAF onto triangle JOS. Make sure that you have the original drawn with the given and the prove, as well as the steps written with the diagrams next to them, because it's important that you see what we mean when we rotate and translate and everything else that's going on. So let's try to verify the side postulate. Given that side TD is congruent to side EN, side YT is congruent to side SE, and side YD is congruent to side SN. So again, we know the side postulate works to prove that two triangles are congruent, but we want to show that they're congruent using a series of rigid motions. So first what we're going to do is translate triangle YDT so that point D and point N coincide. So this obviously isn't accurately drawn, but we are going to translate it basically to get this point and this point to coincide. So we're going to translate these down so that this is YTD, and we have something like this. Then, since line segment TD and line segment EN are congruent, you can rotate triangle YDT so that line segment TD and line segment EN coincide. So we started off by translating it so that they coincide. Then we are going to take our blue triangle, YDT, and we're going to rotate it so that line segment TD and line segment EN coincide. When we do that, this is going to be our D, this is going to be our T, and that means that this is going to have to be our Y. Because we know that YT is congruent to ES and YD is congruent to SN, we know that these sides are going to perfectly coincide. They're going to overlap. So that means that we're proving that triangle YDT is congruent to triangle SNE by first a translation and then a rotation. So a series of rigid motions that perfectly show that the two triangles are congruent. Because we were given three sides, there are transformations, rigid motions specifically, that can be done so that all of the sides perfectly coincide and we can show that the two triangles are congruent by first a translation and then a rotation.